Hello and welcome everyone. This is my first video in this channel. In this video, I want to explain about what this channel is about and what you can expect from it. The title of this channel is AI Cat Risk Expert, or ACR as the acronym. As you can expect, contents in this channel will be related to AI, cat, and risk, but not expert. Expert is my self-claimed role because I do have many years of professional experience on these related contents. The contents of this video contains the following: what is risk, its definition, risk metrics, and ways to quantify risks. What is the cat here? The cat here is not the pet cat people love, but an acronym for catastrophe, the rare but extreme consequence of risk. I also want to explain why AI has to be introduced to be with cat and risk. Finally, I will talk about future contents of this channel. If you like this channel, please subscribe to it. Your subscription is highly appreciated. Risk is everywhere, and our life is full of risks. For example, random gunshots in Chicago or other cities, traffic accidents on highways, and even getting sick due to bad food are all real-life risks. The list can go on and on. Technically, risk has an official definition. According to ISO 31000 version 2018, which is risk management, risk is defined as the effect of uncertainty on objectives. This is very college textbook style definition and confusing to most people. But do not worry, you only need to know that uncertainty is the keyword. Risk has to be associated with uncertainty. If everything is certain, then there are no risks. There are two components in any risk, which are the likelihood and the consequence. Likelihood is the probability of occurrence, which defines the possible occurrence of the risk. Consequence is the severity after the occurrence of the risk event. Given these two components, risk can be defined as the likelihood multiplied by the consequence. In other words, we first need to know if the risk is to occur. Then we need to know, given that the risk has occurred, what is the consequence or damageability of the risk? The two combined will yield the result for risk. Since risk is everywhere, we need to assess the risk whenever a decision has to be made. As explained previously, risk has two components, likelihood and consequence, and risk is the multiplication of these two. If we use the vertical axis as the likelihood and the horizontal axis as the consequence, then risk can be schematically shown as the product of the two. Although we use a straight line to show the risk axis, in reality, risk does not have to increase linearly with either likelihood or consequence. Along the risk axis, we can set up zones based on predetermined threshold risk values. The number of zones can be arbitrary, and it can be adjusted based on the requirement in different scenarios. For example, a three-zone approach is often used. That is, the risk is divided into the low, medium, and high-risk zones. Alternatively, if we draw both the vertical and horizontal lines according to the grading of likelihood and consequence, then a matrix can be formed as shown here. Each element or grid in this matrix corresponds to a given likelihood and consequence grade. And then the risk value can also be attached to the element. This grid-style matrix is called risk matrix and is widely used in different types of risk assessment. We all know there are many risks in life, and they do not exist independently. Most of the times, risks can interact with each other, resulting in compounding consequences. The interaction between different risks is also called coupling in technical terms. The coupling process is very complex, and it can generally be categorized into three types. One is random coupling, which means that there's no physical or mechanical connection between the risks. They just happen to occur near each other in time and space, causing compounding consequences. For example, a heavy rain after an earthquake not only results in difficult efforts for search and rescue, but also causes additional damage to the damaged area. The key feature of random coupling is that scientists have not found direct connections between the risks. The second coupling is the likelihood coupling, which means that the risks often occur simultaneously, and there is scientific evidence that the risks are interconnected in the occurring process. For example, a hurricane, storm, and flood can happen at the same time because of the same hurricane event. The key feature of this category is that scientists have proven the interconnection between the risks. The final type is consequence coupling, which means there is causing effect between risks. People often use another term, which is catastrophe chain reaction, to describe this causing relationship, which means that when one risk occurs, it causes another risk and so on. For example, during a heavy rainfall, landslide happens because of the rainfall, and landslide damages the houses in or after the sliding process, and this chain reaction goes on and on. You can easily identify many similar examples of risk chain reactions in our daily lives. As can be seen here, due to the complexity of risk coupling, the simple risk matrix approach explained before is not suitable for risk assessment here. A more scientific and/or engineering algorithm needs to be found to best quantify the risk, which is a topic we can cover in the future if there is sufficient interest from the viewers. When risk is talked about, the perception often appears to be that risk is always a bad thing. This is not necessarily true. People often tend to take the easiest route if there's a choice, and we all want an easy path. Because of uncertainty, risk also brings with it the opportunity. Of course, opportunity can result in both good and bad things, or profits or loss in other terms. If opportunity is taken, but if you want to outperform the average, you need to take the chances once in a while. Whether to take a chance requires complex decision making, and the quantification or risk assessment comes handy at this time. People often talk about risk and reward, which means that if you want to get better results, you will need to take risks. Therefore, risk assessment not only helps you avoid potential downhills, but also presents you opportunities once in a while. The key is to make a right decision based on your risk assessment when the opportunity appears. Now let's move on to a special type of risk, CAT, or catastrophe. By definition, catastrophe is an event that causes great and often sudden damage or suffering. Catastrophe has two unique features. One, it has to be rare and does not occur frequently. The other is that once it happens, the consequence is severe or even disastrous. There are many examples, such as natural disasters of earthquakes, hurricanes, tornado hails, and even man-made disasters such as large-scale terrorist attacks or even wars. Because of the scarcity of past examples, there is not enough evidence or data that helps us determine the likelihood. And due to its severe consequence, we just cannot ignore this type of risk. Understanding catastrophe risk requires advanced knowledge of science, engineering, and mathematics, and the risk assessment of catastrophe requires complex quantification modeling. We may cover this topic in future if there is sufficient interest from the viewers. Now we come to the topic of AI. AI stands for artificial intelligence and has been very popular these days. We have seen many successful AI stories from the news, such as AI beats the best Go players, AI is better than doctors in hospital diagnosis, AI is better than music composers, and AI handily beats world's best poker players. The successful stories of AI are actually related to an improved algorithm called machine learning. Machine learning is the core to AI, but they are different. The term AI was first used in 1956 by John McCarthy in a Dartmouth summer research project on AI. By definition, AI means intelligent machines having the ability as humans do. The key here is the intelligence. Machine learning, on the other hand, was first proposed by Arthur Samuel in 1959, and it means the ability given computers to learn without explicitly programming the computers to do so. Nowadays, people tend to use AI and machine learning, but there is a slight difference between them. AI focuses on intelligence and machine learning concentrates on learning, indicating that AI is broader than machine learning. Interestingly, people often believe that AI was first proposed by John McCarthy, but the concept was actually first proposed by A.M. Turing during 1950, 6 years before John used the term. Yes, this Turing is the famous Turing whose name is used to name the machine Turing machine. Now let's talk about why we need AI to assess risk. As explained before, some risks, such as catastrophe risk, require complex quantification modeling. And due to our limited knowledge, traditional methods of risk assessment are not sufficient. As AI is successfully applied in many fields to address complex problems, it is desirable to introduce AI to help quantifying catastrophe risk. The early stage of quantifying catastrophe risk is often relied on statisticians taking an average of everything and then applied the effect variance to help the risk assessment. But this is not enough, clearly. There's a famous joke about two statisticians crossing a river of 6 feet water depth. One statistician is 6 feet 6 and the other is 5 feet 10. The average is 6 feet 2, so they believed they could cross the river, resulting in drowning of that poor 5 feet 10 guy. Although more scientific and engineering knowledge has been incorporated into the catastrophe risk assessment, it's still not enough. We still cannot accurately predict the catastrophe risk. Therefore, introducing AI to help the complex risk quantification problem becomes a natural choice. The early application of machine learning in catastrophe risk quantification has yielded better than expected results. So we believe that big data and the machine learning approach, incorporating the benefits of traditional approaches, are the future direction of risk assessment. Therefore, this channel is named as AI Cat Risk Expert. Finally, let's talk about future potential contents in this channel. The goal is for both information, education, and entertainment. We want to help you understand risks in various scenarios. and want to be helpful, but we do not take any responsibility or liability of our views, actions, or consequences. We try our best to make no mistakes, but they do happen once in a while. If you see one, please let us know. This channel is about risks, especially catastrophe risks. So anything related to risk, if believed to be interesting to our views, will be discussed in this channel. As we talked before, risk is everywhere in our life, so any topic can appear in this channel, but when the topic does appear, it will always be viewed from a risk-aware point of view. Please know that risk is both a good and bad thing. So our objective is to help our viewers to avoid the bad part and enjoy the good part. So stay with us and let's rock on with a risk-aware state of mind. Thank you.